understood this is the final balanced equation. This method of balancing is called hit and trial method. Remember, we should always use the smallest whole number coefficient to balance any equation. Writing physical states. Let us see these two equations. They are balanced, but they are not explanative. That is, they don't give any information about the physical state of the element or the compound present in the equation. To make it more informative and explanatory, we write the physical states next to the compound or the element. Physical states are represented within the brackets. For gaseous, we represent it by small g. Liquids we represent by small l. Solids by small s. And aqueous solutions by aq. Aqueous means the product or the reactant is present in a solution of water. In the equation, temperature, pressure, catalyst and other reaction conditions are mentioned above or below the arrow. To make it more informative, let us see the examples. The catalyst is represented above the arrow and the temperature above the arrow. Types of chemical reactions. We know that atoms of one element does not change into atoms of another element, nor atoms disappear from the mixture and appear elsewhere. What happens in a chemical reaction is there is making and breaking of bonds between the atoms. There are large number of reactions and all these reactions come under these four types, and they are combination reaction, decomposition reaction, displacement reaction and double displacement reaction. Effects of oxidation. Corrosion. We see that iron loses its shiny texture when used for a long period of time. It is converted into brown powder, simply called as rust. Even other metals like silver and copper, when come in contact with moisture or other acids, gets corroded, and this process is called corrosion. Corrosion causes damage to car bodies, ships and all other substances which are made up of metals. Corrosion of iron is really a serious problem. Large amount of money is spent to replace them periodically. Rancidity. Fats and oils after oxidation become rancid. That is, they taste and smell different. To prevent rancidity, we use antioxidants, airtight containers and gases like nitrogen. Now, how do we come to know whether a chemical reaction has taken place or not? Let us perform some experiments in our virtual lab with our friend Professor Proton. He will be helping in all our experiments. Experiment 1. Let us take magnesium wire and burn it. We observe that magnesium wire burns with dazzling white flame, and we can see that it is converted into a white powder. Now let us perform magnesium ribbon experiment. Proton. Now take a pair of tongs. Place the magnesium wire and heat it over a spirit lamp. We observe that the magnesium wire is burning with dazzling white flame, and we also saw that there is a white powder collected in the dish. This is due to the reaction of magnesium with oxygen, and the white powder is magnesium oxide. Now moving on to the next experiment. Proton has a conical flask with zinc granules in it. He is taking a test tube of hydrochloric acid and adding to the conical flask. We observe that hydrogen gas is evolved, and we also observe that the conical flask is heated up. Moving on to the next experiment. Professor Proton has two test tubes, one containing the lead nitrate and another the potassium iodide. Now he is adding the potassium iodide to the lead nitrate solution. As soon as the mixture mixes, it turns into bright yellow color. Just observe it. Thank you, Proton. Now, after observing all these experiments, we saw that there was change in color, change in temperature, evolution of gas, and change in state. All these factors determine whether a chemical reaction has taken place or not. Combination reaction. Proton, now take a beaker and place calcium oxide in it. Add water slowly to it. Now we see that calcium oxide reacts vigorously with water, and the products of the reaction are calcium hydroxide. Now we also observe that large amount of heat is evolved during the reaction. This can be felt by touching the outer surface of the beaker. We saw that calcium oxide and water combined together give a single product, calcium hydroxide. We also observed that there was large amount of heat evolved. So the reactions in which heat is evolved are called exothermic reactions. Let us look into some more examples. Burning of coal. Carbon plus oxygen giving rise to carbon dioxide. Formation of water. Hydrogen plus oxygen giving rise to water. In all these reactions, two or more reactants combine to form a single product. These type of equations are called combination reactions. Decomposition reactions. Decomposition reaction is quite opposite to that of a combination reaction. In decomposition reaction, one single compound breaks down into two or more other compounds or elements. In decomposition reaction, there is a need for energy source such as light, electricity or heat energy. Let us perform an experiment. Let us take calcium carbonate in a test tube. Now let us heat the test tube over a spirit lamp. We observe that calcium carbonate is decomposed into calcium oxide and carbon dioxide. And the reaction is calcium carbonate decomposing to calcium oxide and carbon dioxide. Now moving on, let us take lead nitrate solution in a test tube and burn it over a spirit lamp. We observe that there are brown fumes around the test tube. This is because of the evolution of nitrogen dioxide. Lead nitrate upon heating gives lead oxide, nitrogen dioxide and oxygen. This is an example for decomposition reaction. Proton. Now take a china dish and place silver chloride granules in it. Proton. Now go keep the dish near the window such that the sunlight falls on it. Proton. Now come back. Let us perform an experiment. Proton. Now take a plastic mug and drill 2 holes in it. After drilling 2 holes, place 2 electrodes into it. After placing the 2 electrodes, connect it to the battery. After connecting it to the battery, pour some water into it and add sulfuric acid in small amounts to this. Proton. Now take 2 test tubes of water and invert them and place it on the electrodes. Now switch on the battery such that the current flows through the electrodes. After some time, we observe that there are bubbles displaced at each tubes. This is because the water has displaced into hydrogen and oxygen. Now we observe that water decomposed into hydrogen and oxygen. Remember, earlier we kept a dish into the sunlight. Proton. Now get the dish back. Do you observe any difference? Yes, the white crystals of silver chloride has changed into grey color. This is due to the decomposition of silver chloride into silver and chlorine. In all these experiments, we saw that we use some sort of source of energy like heat, electricity or light. Hence, the reactions in which heat is absorbed are called